write a program for computing the time period of a pendulum, right? So for that one, the process is to open Notepad++, right? Or simple Notepad. Here it is, Notepad++. And during the time, I also open the command prompt. It is required. So let's write a brand new program. So a new file from here, and let me zoom that one so that everyone can see. So it's a program. I will get to column number 7. So you may check that one from the bottom. Let me see whether I have an option to annotate or show some pointer. Okay. So I am in column 7. I will write program, right? So 6 characters. I generally prefer to limit the names to 6 characters, and I write here end program pendulum, right? So with that one, let's save this program to the directory where I saved last time the program, right? So save as, this should be saved as a Fortran file. So last time I saved the program in G directory. So here is the G77 compiler, and in the bin directory we generally save the programs, and it should be a Fortran file, so fixed source file or the free form file. So actually it is a fixed source file, but just to get the benefit of highlighting of the text, coloring of the text, I use Fortran free form file. The old file we did yesterday last time is available here, right? So Fortran file, and I will set the name pendulum.for or .app. So the moment it is selected, we will see the coloring of the options. So the first part should be the description, right? So this program is going to get some inputs and outputs. So I would say input should be the length of the pendulum, right? So length in centimeters, right? And you should complete the rest of the parts, right? So here I generally write it in this structured way. Let's define our variables by ourselves, because L is going to be identified as an integer. Therefore, let's define it as a real thing, right? So it is length of the pendulum. So you can also use some other variable, right? Right. Compromise on English as well. What else we require? We require a pi in the expression, right? So let's define real as pi. Yes, we can write that. We can write that in the same line, right? It is conventional way of doing the programming, because when we define this one, after that we define it refers to length of pendulum. So actually this is constant. What else is required? We have to define a G value. So G value, and it should be limited, right? We are taking length in centimeters, therefore this would be 980 centimeter per second square. So second, right? And then we require the time period. So that is going to be the output, right? Right. So now let's define pi. So pi is equal to, people sometimes define it like this. Sometimes people define it in this way. A tangent of 1.0, right? What is this number? Tangent inverse of 1 for 45 degree, pi by 4. So if I multiply it with 4, that would be the pi value, right? Okay, now after the declaration of the variables, here now I would require the calculation. So calculation, I said t equal to 2 multiplied by pi. So small or capital, there is no difference, but let's be consistent. Then square root of length length divided by g value, square root of it, and that's it, right? So then, but we have not defined the values of length and g and the rest of the thing. So here, since I didn't make things on piece of paper, therefore I'm doing now back and forth thing, right? So pi has been defined. We have to define g value. So 981, right? Point, or it is not required, right? So then what else have to be defined? So we require a value of length. Let's get the value from a user. So just like print statement, I can use a read statement. So read length length. So just to make our program interactive, I write here a print statement, print asterisk, I would say enter value for length of pendulum, right? In units of centimeter, right? Right. So now everything is clear. So time period would be returned in seconds, right? So this is the calculation part. Let me delete the extra lines. So after that, let's write the print statement to get the answers. So I use the simple statement, time of pendulum on the basis of simple pendulum strategy, time period, right? And I will return it with the variable t, right? So this is the program. If we look for the option, the program file color, so it is red. It means it is an active file. So let's save this one, right? So now it has turned blue. It means all the contents have been saved, right? So now time is to run the program. So we have to get to the respective directory, not this bin folder. I have to get to the directory G, where the brand new G77 compiler is there. And in the bin directory, our file is there. And we have to access this directory from terminal. So here we go. So G directory, Z directory. So I write CD, and with the tab sign, I can see the directories. So G77 directory is there. In G77 directory, there is a bin folder, there is documentation folder, library folder. This is with the tab key, right? So I require the bin folder. So in bin folder, if I press the enter, so I'm now in bin directory. The contents of bin directory can be seen by writing the dir command. So here my file pendulum.for is there and the compiler G77 is there. So to link that one, so here the compilation command G77 pendulum.for, right? I will suggest a name for my file pendulum.exe, right? So the object file will be created. Behold, with your silence, my experiment is much more serious than the experiments of physics performed by Professor Walton. Yes, programming works. Compilation command has been successful, and we have generated a file pendulum.exe application file, right? But the time is to test this file, right? So I will call this file pendulum.exe, or just pendulum means this file is there. So enter a value for length of pendulum in units of centimeter, right? So 100 centimeter, right? It's a special pendulum with the length 100 centimeter or 1 meter length. Its time period is 2 seconds. Is it right? Okay. So do you like to check? It is a seconds pendulum. Its time period is 2 seconds. You might have solved this problem in the reverse order, right? So now this program, this application file is independent of the computer. And this is for just for the problem where the length is provided in centimeters, right? G value is in 981. We have preserved that. We have defined the pi value, and the answer for time is returned in only in seconds, right? So if this limited capability application is a requirement for someone, you can sell that one, right? If somebody is interested in getting the time periods of different pendulums, so that file is there. Dobara run, if we want to run it again, so we call the file just by the up arrow key. With the up arrow key, it is going to show me the old commands with which I started. My first command was G with the colon notation. And then I get to the directory, then the directory contents, then the compilation command. And that's it. If you want to update the file, so you have to again get to the file, make some changes, improve the documentation, right? So that it is much more user friendly. Inform the user about the units you are using, the constants you are using, right? So that's writing the professional programs. I run it again. So it is again asking me for some uh, length in centimeter. So 1.4. Let's check at what pendulum its length is, its time period is 1 second. That is practically the behind the first watches. 1 second time period. If it repeats 60 times, then update 1 minute, and then again 1 minute and 1 hour behind the mechanical watches. So let's find out that time. So 50 centimeter, let's check 40 centimeter, 1.2. I have to further reduce that length. The next part that I am doing is solving a non-linear equation, but not by some method, just by hit and try. So 35, 1.18. I have to further reduce 30. 28. हाँ, बाकी आप घर में जाके करें. the rest of the expectation, for rest of the expectation, please do ask from the compiler. So let me stop the recording. Experiment has not been finished. So let me stop the recording, and after stopping the recording,